Lesson 2.6 is all about proving angles congruent. So you're going to see a lot with angles in this lesson, okay? Very geometry-based proofs here. But the first thing we need to talk about, it's called the vertical angles theorem. Okay, vertical angles theorem. If you are using the vertical angles theorem in a proof, I am okay with you calling it VAT. I don't usually do VAT, I don't know why. I just always got in the habit of doing the word vertical and then an angle behind it, the symbol. So that's usually what I will do, but if you put VAT in for vertical angles theorem, I know what you're talking about. You are welcome to do that, okay? The vertical angles theorem, if you have a setup like this, where this is angle 1, angle 2, angle 3, and angle 4, can you tell me what we know are vertical angles in here? Which angles are vertical angles? Heather, change your mind. What are our vertical angles? Yeah, say here. 1 and 3 are vertical angles. Okay, so the vertical angles theorem says when you have vertical angles, they are congruent. So that means that angle 1 is congruent to angle 3, and it means that angle 2 is congruent to angle 4. Okay, so the vertical angles theorem says that vertical angles are congruent. Any questions on that? Okay. You're going to use that one a lot in proofs in general. Vertical angles theorem shows up quite a bit. So look for it when you're working with angles in a proof. It will likely show up. All right, let's do an example of that. So if I tell you to solve for x, and the problem looks like this. If we have, God bless you, 2x plus 21 and 4x, okay? If I tell you to solve for x, what am I looking for? What do we have to do with this? Yeah, Sam. Right, you just set them equal to each other because vertical angles are congruent. So 2x plus 21 equals 4x. And then we solve for x. So take away your 2x. And you get 2x equals 21. Divide by 2. What's 21 cut in half? 10.5, 10.5, or you can leave it as 21 over 2 technically if you left it as an improper, okay? But you're just solving for x. Now, if I asked you to tell me the measure of each angle, then you could plug it in and solve for the measure of each angle. For this one, it just said solve for x, so we're not going to plug it in, but you could always check your answer by plugging it in because they should be equal, right? So once you plug it in, do you get the same values? Questions on that? Okay, that is vertical angles. So we're going to do a proof involving some vertical angles. And I'll write this all out, and then I'll give you a second just to catch up if you're writing with me. So given that angle 1 is congruent to angle 4, we are going to prove that angle 2 is congruent to angle 3, and our picture is this. Okay, what is our first step? The given, right? So we're going to say we know that angle 1 is congruent to angle 4 because it was given to us. Okay, and if you want, sometimes it helps people to mark it up as you go. So because we know 1 is congruent to 4, you could mark it that they're congruent if that helps you. You don't have to, but you can. Okay, so 1 is congruent to 4. What else do we know in this picture? We're trying to prove 2 is congruent to 3. We don't know that. What did I heard something over here? Yeah. Okay, and what's true about vertical angles? They're congruent, right? So I can say, and you can break this up into steps if you want. I'm going to, because I did it in my last class and I confused them. So for the sake of not confusing people, we're going to break it up one at a time, okay? We know that angle 4 is congruent to which angle? 2, right? Angle 4 is congruent to angle 2. And why do we know that? Because they're vertical angles. So you can say vertical angles, or this is where you could say VAT if you want, okay? So those are vertical angles. Okay, now look at our first 2 steps. We said 1 is congruent to 4 and 4 is congruent to 2. What conclusion can you make from that? Think law of syllogism here. You can say that 1 is congruent to 2 by getting rid of that stuff in the middle. That's the same. Which property is that? Transitive. That would be the transitive property. Okay, so now we know 1 is congruent to 2. We're trying to prove that 2 is congruent to 3, which we can't quite do yet, but we're getting close. We also said we know, yeah, Angie.
Wait, can you explain the transitive property again?
Right, so if you look at 1 and 2, it says 1 is congruent to 4 and 4 is congruent to 2, therefore 1 is congruent to 2, right? Take out the 2 that are the same and what you're left with. So that would be transitive. Heather.
Because 1 is a vertical angle to 3, so maybe 3 is congruent to 1.
Yes, so we're going to say angle 1 is congruent to angle 3 because they are vertical angles. I'm just going to write the VAT. Again, vertical angles or VAT. You may write either. Do you guys have a preference? What are you going to use?
Vertical angles.
Vertically. So both. Okay, we're just going to use both. If this is what you're going to use, you're going to write vertical angles. Okay? All right. So now, notice where we're at. We just said, go back to 3 and 4. We said 1 is congruent to 2. And 1 is congruent to 3, therefore, what? 2 is congruent to 3. Take the 2 out that are the same, you're left with angle 2 is congruent to angle 3. Why? If 1 is congruent to 2 and 1 is congruent to 3, then 2 is congruent to 3 is the transitive property again. Okay, so in the end, they're all congruent. What does that make them? If they're all congruent, they're all 90. They're all right angles, okay? But we didn't have to prove that, so we'll stop there. But that would be your proof, okay? Now, technically, you could have put 2 and 4 together as one step, but that's what I did last time, and I confused people. So this is probably the simpler way to understand it, okay? Questions on that? Okay, did I tell you yesterday that you never have to write a paragraph proof? Okay, just know in the book, if they ask you for a paragraph proof, you may write the 2-column version every single time, okay? If you want to write a paragraph, by all means write a paragraph, but I'm going to give you 2-column proofs, so I would like you to get in the habit of doing those. But again, up to you if you want to try them that way. Okay, I have 2 theorems for you. The first one is called the congruent supplements theorem. The second one is called congruent complements theorem. Hey. Very similar theorems. What's the difference? Supplement and complement. What are supplements? Supplements are 2 angles that add up to 180. What are complements? 2 angles that add up to 90. Okay, so the congruent supplements theorem says this, and I will tell you it, but show you it as well. So here's what it looks like. This is angle 3. And then you have angle 1 and angle 2. Okay, in words it says this. I'm not going to write the words. I'm going to write the equation that says what the words say. Okay, but the words say this. If 2 angles are supplements of congruent angles or the same angle, then the 2 angles are equal. Okay, in other words, what they're saying is if the measure of angle 1 plus the measure of angle 3 equals 180, and the measure of angle 2 plus, the measure of angle 3 equals 180. Okay, so if 1 plus 3 equals 180 and 2 plus 3 equals 180, then the measure of angle 1 is congruent to the measure of angle 2. Okay, think about what that's saying. If this was, and this is just a for instance, these are not numbers that have to be, okay? This is just one example of what it could be. If this angle is 120, in order for angle 1 to be supplementary to it, it would have to be 60, right? In order for angle 2 to be supplementary to angle 3, angle 2 would have to be 60 also, which means 1 and 2 will be the same measure. Okay, that's essentially what the congruent supplements theorem is saying. Congruent complements theorem says the same thing, but instead of 80s, you have 90s. Okay, so basically you're just rewriting this with 90 and 90 in place of the 180, right? So if I have these 3 angles, where this is angle 1, angle 2, and angle 3, if I say if the measure of angle 1 plus the measure of angle 2 equals 90, and the measure of angle 3 plus the measure of angle 2 is 90, then what is true? Then angle 1 is congruent to angle 3. Okay, I switched my numbers around, but same idea. Any questions on either of those theorems? Okay, there is a theorem, it's called Theorem 2.4. I will never ask you to give me the number of it, but at times you will use it just in a proof, so maybe I should just write it down for you. Oh, look at that. We shrunk way down. Here's what this first theorem says. It says all right angles are congruent. My guess is every single one of you already knew that. What is a right angle? 90 degrees. So basically they're saying every 90-degree angle is the same as every other 90-degree angle, right? but you do use it at times. You'll see when that comes into play. The other theorem that maybe isn't quite as intuitive is this. It says if two angles are congruent and supplementary, if two angles are congruent and supplementary, then, can anyone fill that in for me? If two angles are congruent and supplementary, what do we know about them? They're right angles, right? Then they're both right angles. Okay. So think about it like this. You have two angles, and all they tell us is those are congruent, but they form a straight line. Well, in order for them to be equal and forming a straight line, the only option is that they are both 90 degrees. Okay? All right, we're going to do one proof of the congruent supplements theorem just to show you why that theorem is true, and then we'll be done. And we got to move fairly quickly here. So given that angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary, we're going to prove angle 1 is congruent to angle 2. So since we're doing a proof of the congruent supplements theorem, you may not use the congruent supplements theorem as a part of your proof, because we're trying to prove right now why it's true. Once we've proved it, then you may use it in theorems. But right now we're just trying to prove why this is true. So let me draw you the picture. So let's say this is 3, this is 1, and this is 2. All right, what is the first step of your proof? The given, okay? Now, in this setup where you already have it written down, I would do this. Just put a box around that, draw an arrow to your first blank here, and write given. Okay, so that's your given information. We know 1 and 3 are supplementary. We know 2 and 3 are supplementary. If we know they're supplementary, what do we know about them? What does that mean? They equal 180. So we're going to say the measure of angle 1 plus the measure of angle 3 equals 180. And we're going to say the measure of angle 2 plus the measure of angle 3 equals 180. Why can we say that? What did they tell us in the given that tells us 180 in step 2? That they're supplementary. So you just say that's the definition of supplementary angles. They equal 180. Okay, definition of supplementary angles. So then for my third step, I'm going to say the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. Can anyone tell me why I can say that? So I had this. What did I do to get this? Sam.
You supplemented the left for the right?
Not supplemented. What's the word? Think basketball. Substitution, right? I took out the 180 and I put in what I know 180 equals. So you can call this substitution, or you can call it what? Transitive, right? Take out the two that are the same and set them equal. So transitive or substitution. You can do either. Don't pack up, I'm not done. Okay. So then, for my last step, the measure of angle 1 equals the measure of angle 2. How do I know that 1 equals 2? What did I do to both sides?
Took out the 3.
I took out the 3. In other words, I subtracted the 3. So that's the subtraction property. Okay?